That y1 is 0.095, h is 0.1 by 2, f of x1 is 0.1, 0.095 plus f of x1 is 0.1 plus 0.1, y1 is 0.095 plus 0.1, f of 0.1 and 0.095. Okay, we have just substituted the functions values, the index values, x1, x2, x3 and so on, x1, y1's value, and after putting the values you have to simplify it. On simplifying and applying the functions, I'm writing the result directly. We get 0.18010. We can call it up to 4 decimal 0. So this is the output after using the index m equals to 1. And similarly, we can proceed for the third unknown by changing the index directly. So here I am putting m equals to 2. Here it gives you 3. On the right side, y2, x2, y2, x2, y2, x2 and y2. And next you have to put in the values. On putting the values, this is your y2, so this becomes 0.1810, 0.1 by 2, x2 is 0.2, 0.1810 plus f of x2 0.2, 0.1, y2 is 0.1810 plus 0.1 and function fx is 0.1 and 0.181. Okay, so this is the substitution of the values of x2 and y2, and on simplifying and simplifying the function as well, we'll be having the output in the form of 0.2588. This is the third unknown which we were looking for. We got y1, y2 and y3 so far, and now we got the corresponding values. After finding these values for the two methods, the Euler's and improved Euler's method, now we want to see which method is giving us the better answer. So in order to do this, we'll be taking help from the exact solution of the differential equation which we have for this particular case. The original differential equation is dy by dx equals to 1 minus y along with the initial conditions of y0 and 0, and the exact solution of this equation is y is equals to 1 minus e raised by minus x. Okay, now to approximate the solution for the corresponding m1, m2, m3, we introduce here the index ym on the left side, 1 minus e raised by minus xm on the right side. Let me make all these calculations here. Taking m equals to 0 gives you y0 on the left side. We basically are looking for y1. We have to take start from m1. y0 is already given, there is no need to calculate it. So here we put m equals to 1, 1 minus e raised by minus x0, and x0 is 1 minus, let me write it here, 1 minus e raised by minus 0.1. If you can use your calculators, you will be able to find out the results very easily directly, no problem at all. I hope you can do it. So the result is 0.095 and 2. For m equals to 2, y2 is equals to 1 minus e raised by minus x1. This is equals to 1 minus e raised by minus 0.2, and we get 0.095. 1813. Similarly, I hope you can do it the next one of yourself. So I write down the direct result here, 0.2592. So we got all the three results, and these are the exact solutions. Let me highlight them. This is your first value, second value, and the third value. Now, if we write them in a single format in the form of a table, so then we can make the comparison of all these two results with the exact solution and decide which one is giving us a better result. So let me construct a table of values for all these results. The method so far we have used values of x, the Euler's method, the improved Euler's method, and then we have used the exact solution. So these are the major heads under which we have to put in the values. So let me erase it from here, and I bring all those values in the form of the table. Initially, when x was equals to 0, Euler's was giving 0 everywhere. This is not a part of the solution actually. 0.1. 0.1 gives you 0.1 for the Euler's, 0.2, 0.3. We get 0.19 and 0.271 for the Euler's case. For the improved Euler's case, we have 0.095 and 0.1810 and 0.2588. And the exact solutions are 0.095 to 0.1813, 0.2592. So now you can make the comparison of these results. So obviously these are more related or more close to the exact solution as compared to the Euler's method. So the improved Euler methods gives you the better results comparatively to the Euler's method. But main thing is the improved Euler's method is entirely based upon the Euler's simple method. So this was the whole story for the today's talk. And if you still have any questions or queries in your mind, you can discuss. You can find many similar kinds of problems in your textbooks and try to solve them at home, and inshallah you will be able to solve a variety of problems by using these methods. So till here, thank you very much, and Assalamu alaikum.